Hi dear students, in this presentation we will discuss about thermochemical conversion of the biomass into fuel. Last presentation we were discussing about agrochemical conversion, in which the fresh plants are used for the fresh plants are being used as the biomass for the production of the fuel, or even some plants are cultivated for that particular purposes itself, and finally the plant from which the biomass is produced remains as such, or it is kept alive, and we are not hammering that particular plant. That is what is known as agrochemical conversion of the biomass. Here in thermochemical conversion of the biomass, as the name indicates, there will be some heating. Thermo means some heating will be there, of course, with some chemical reaction for the conversion of the biomass into fuel. Thermochemical conversion of biomass uses heat and catalyst in order to convert biomass into fuel. By using these processes, the biomass can be converted either into solid fuel, liquid fuel, or gaseous fuel. All this depends on the which processes that we are following. These fuels produced, whether it can be solid, liquid, or gas, whatever it may be, can be further used for the generation of the electricity, or for generation of the heat or chemicals and fuels. Thermochemical conversion of the biomass can take place by the pathways categorized as direct combustion, carbonization, pyrolysis, gasification, and liquefaction. All these are the different conversion processes and coming under thermochemical conversion. So, by all these processes, we can convert biomass into fuel. The which process we are using depends on finally which product we are getting. If you are going for direct combustion or carbonization, that means or even pyrolysis, finally we will be obtaining the solid fuel, uh, whereas in gasification we will be obtaining final product as the gaseous fuel, whereas in liquefaction we will obtain liquid fuel as the final product. Okay, now discussing one by one. First one is direct combustion of the biomass. That name itself gives some idea about how the conversion is taking place. Here biomass is directly used as a fuel for the combustion and heat is produced, and this one is the conventional method, and for a very long year back all are using the same method. Wood is the commonly used biomass and it is directly burned to produce the heat. That is what is direct combustion of the biomass. As we all know, this is a low energy efficient processes, because a lot of energy is lost during this direct combustion process. Complete combustion may not be possible, and as well as it is producing a lot of uh, pollutants. Carbon monoxide, carbon dioxide, everything is produced during the combustion, and which will be a pollutant for the atmosphere. So there are all the drawbacks of direct combustion. In direct combustion, biomass is burned in the presence of excess oxygen. That is what is the importance. Directly we are burning the biomass in the presence of the oxygen, or excess oxygen is available. Why we stress on that excess oxygen term is, in some processes we are not using the oxygen for the combustion. That's why we are stressing on that term. By burning biomass to get the thermal energy is the most common and age-old method of using biomass. The complete combustion of the biomass into ash is called incineration. If the complete combustion takes place, then we will call it as simply incineration. And nowadays, high quality incinerators with high efficiency are available in the market for the complete combustion. If you go for that incinerators for producing the heat, then we can somehow eliminate the energy absorbed from these processes, or we can get a higher energy from the direct combustion also. The main biomass used is wood. It is burned to provide the heat for cooking, comfort heat, crop drying, factory processes, and forming steam for electricity production and transport. The disadvantage of direct heating is that lots of energy is wasted and the smoke produced causes air pollution. That is the main disadvantage. Direct heating is still prevalent in rural or underdeveloped areas. Common people are mainly depending on that particular method for the for converting biomass into energy. By direct combustion, we can produce heat. That is the simplest method. There is no chemical reaction and all. Of course, chemical reaction means combustion is the process of combining oxygen. With the presence of oxygen only combustion is possible. Actually, oxygen is utilized for the combustion. So it can be, we can say it is simply a chemical reaction, but sophisticated chemical reactions are not required in this process. Now coming to the next process, that is carbonization. Unlike the uh, unlike the Unlike direct combustion, in this process we are not providing excess oxygen, or we can say we are combustion is carried out in the restricted airflow or the oxygen availability is restricted during this carbonization process. It is the process whereby wood is heated with restricted airflow to form high carbon product by removing the volatile materials from it. So by doing carbonization, what we will do is we will be removing the volatile materials. What do you mean by volatile materials? Volatile materials are materials which can be vaporized on providing the heat. So from the wood and all, we will be by providing the heat, we will be vaporizing the volatile materials, and the final remaining product will be very high rich in carbon content, and which can easily combine with the oxygen during the combustion process. So high rich carbon content solid is finally produced from the wood. So the remaining volatile materials are removed by this combustion process with the restricted airflow. The product is commonly known as charcoal. So carbonization usually takes place in 4 steps. In stage 1, it is an endothermic reaction. Endothermic means heat is supplied, no heat is generated during the reaction. That is what is endothermic. If it is exothermic, heat energy is liberated. So endothermic, heat energy is consumed. It is endothermic and involves initial drying of the wood. Temperature range is up to 200 degrees Celsius. So in the first stage, we will be initially drying the wood around 200 degrees Celsius, or heat is provided at 200 degrees Celsius, so that the moisture content and all from the wood is removed in the initial stage. In the stage 2, further heating is carried out, that is from temperature range is from 170 to 300 degrees Celsius. In this step, what happens is, it is pre-carbonization stage, which is also endothermic, and it produces some pyroligneous liquids and non-condensable gases like CO and CO2. During the second stage, we will obtain a liquid form called pyroligneous liquid, commonly also known as wood acid or wood vinegar. It will be brown in color and liquid form, that is extracted from the wood by this combustion process or heating process, we can say. So by heating at 170 to 300 degrees Celsius in the restricted airflow, what happens is, along with the pyroligneous liquids or wood acid or wood vinegar, non-condensable gases, these gases cannot be condensed, that non-condensable gases CO and CO2 also is liberated during this stage. So in this stage, we are getting one fuel, that is pyroligneous liquid, that can be directly used as the fuel. In third stage, we will be further heating, or heat is further provided in at higher temperatures. But the difference from the second stage is, here it is exothermic stage. This is exothermic within temperature range of 250 to 300 degrees Celsius. Exothermic means during the chemical reaction, heat is also liberated. At this stage, greater proportion of the light tar and pyrolignite acid produced in the second stage are released from the wood to produce residue of wood, which is called charcoal. See, during the second stage itself, pyroligneous liquids started to separate from the wood, but not in a greater proportion. Along with that pyroligneous liquid, non-condensable CO and CO2 are more produced. The pyroligneous liquid produced will be lesser in quantity, but during the third stage, more pyroligneous acid is produced. In the second stage, more quantity is produced in this stage, as well as so that means the liquid content is completely removed from the wood. That means the remaining will be pure solid, and it is commonly known as charcoal. So charcoal now means it will be in the solid state with high carbon content. So everything volatile materials already removed in the stage 1 itself, and in the stage 2, the liquid contents which are present in the fuel form, even gaseous form, which also can be separated from the wood, is released during the stage 3. And in stage 4, the temperature is above 300 degrees Celsius. Here, bulk of the remaining volatile component of the charcoal are driven off. See, if any volatile component is still left out with this charcoal, that is being removed by the fourth stage heating, that is above 300 degrees Celsius. So the remaining volatile components of the charcoal are driven off by this process. Thus, it increases the carbon content of the charcoal. So finally, what we will obtain by carbonization is the pure charcoal. Charcoal is nothing but the high rich carbon content of the solid produced from the wood. That's all. Okay. So the remaining products and all is removed. See, non-combustible CO and CO2 initially itself it is removed. In the first stage itself, volatile materials are removed, and in the third stage, we are along with charcoal, we are obtaining a liquid fuel also. That is what is known as wood vinegar or wood acid. Okay. So that is brown in color and liquid in by phase it is liquid. Okay. Now coming to the third important processes, that is pyrolysis. It, it is the process where organic material is heated or partially combusted with restricted supply of air to produce secondary fuels and chemical products. See, the pyrolysis also same as that of the earlier one, that is carbonization. But the only difference here is carbonization is initially done to produce the charcoal, or carbonization is the method of producing the charcoal, and it is mainly meant to produce the charcoal. Whereas in pyrolysis processes, the final product can be final product depends on the rate of heating and residence time, temperature level, etc. So depending upon all these factors, the final product also will be varying, and we will be getting even gaseous fuel as the final product, liquid fuel as well as the solid fuel. So everything is possible with the process of pyrolysis. Here the heating rate, residence time and the temperature level is varied. So depending on how we are varying all these parameters, the final product will be obtained. Here also the process same as that of the carbonization, only here also what we do is we will be heating the organic material, or partially we are combusting. We are not allowing complete combustion we are not allowing, with the restricted supply of the air. That is what is the highlight. It is the process where organic material is heated or partially combusted with restricted supply of air to produce secondary fuels or chemical products. The rate of pyrolysis depends on the composition of the material, heating rate, residence time and temperature level. Depending on thermal environment and the final temperature, pyrolysis will yield. See, these are the set of conditions based on which what we will get is discussed here. See, we will be getting biochar at low temperatures less than 450 degrees Celsius. That is, at less temperature, if the heating is done at lower temperatures, when the heating rate is quite slow, if these two conditions are satisfied, then from the organic material what we will get is called biochar. Okay, so temperature is less than 450 degrees Celsius, and the heating rate also should be very low, then the product will obtained will be biochar. And if at high, we are heating at high temperatures greater than 800 degrees Celsius with rapid heating rates, then the product obtained after the process of pyrolysis will be either H2, CO, CO2, CH4 and N2. So all are gaseous products. So if we are doing the pyrolysis at high temperature above 800 degrees Celsius and the heating rate is very high, then finally we will get the gaseous fuels as the byproduct. And if it is in between, if the temperature is intermediate and under relatively high heating rate, but heating rate is very high itself, so at intermediate temperature heating with high relative heating rates, then the product obtained will be bio oil, which will be in the liquid form. Okay, the efficiency and nature of the pyrolysis process depend on the particle size of the feedstock. So by doing pyrolysis process, we have to take care of the particle size, or the feedstock size is to be, we have to make sure that feedstock size is to be very small. Most of the pyrolysis technologies can only process small particles to a maximum of 2 mm, keeping in view the need for rapid heat transfer to the particles. See, we are heating the biomass or the organic materials at a rapid rate, at a high temperature, and also heat transfer should take place within a short period of time. So in order to assure that the surface area is to be increased for the maximum heat transfer, so the size of the feedstock means നമ്മൾ എന്താണോ ബയോമാസ് ആയിട്ട് കൊടുക്കുന്നത് അതിനാണ് feedstock എന്ന് പറയുന്നത്. The size of the feedstock should be minimum, and it is around 2 mm in size. 2 mm means very small size. The demand for small particle size means that the feedstock has to be size reduced before being used for the pyrolysis. So we have to reduce the size of the feedstock into 2 mm size before feeding into the pyrolyzer. A wide range of biomass feedstocks can be used in pyrolysis processes. The pyrolysis process is very dependent on the moisture content of the feedstock, which should be around 10%. So by doing the pyrolysis, the moisture content of the feedstock should not be greater than 10%, or somehow we have to reduce the moisture content to this particular limit. So some pre-requirement is there for the process of pyrolysis, or heating is initially done for the feedstock before going for the pyrolysis process. At higher moisture contents, high level of water are produced, and at lower levels, there is a risk that the process only produces dust instead of oil. So, if the moisture content is more, means high level of water are produced during this pyrolysis processes, and if the moisture content is less than 10%, then there is a possibility that the product, instead of getting the oil as the byproduct, we will be getting the completely burnt dust only as the byproduct. High moisture weight High moisture waste streams such as sludge and meat processing waste require drying before subjecting to the pyrolysis. So, if we are using sludge and meat as the biomass for the pyrolysis process, then we have to make sure that the moisture content is removed from it before going for the pyrolysis process. So, they have to be initially heated before starting the pyrolysis processes. Now, the next thermochemical conversion process, important one, is liquefaction. Liquefaction of biomass is the thermochemical conversion of biomass into liquid fuels by processing in a hot pressurized water environment for sufficient time to break down the solid biopolymeric structure to mainly liquid components. See, in this process, what we do is we will be heating the biomass uh, in a pressurized water environment. See, the biomass feedstock is of small size is initially mixed with high pressurized water in a particular reactor. So, for this process to carry out, a reactor will be there which is operating at a high pressure range from 5 to 200 bar. You see, that much high pressurized chambers are being used, and into that chamber we will be feeding the small sized biomass in the liquid form mixed with the water is provided into this chamber or reactor. Inside the reactor, the temperature will be around 150 to 300 degrees Celsius, and pressure will be from 5 to 200 bar. So, the chemical reaction will be happening within this reactor, and finally we will be obtaining the liquid components. Actually, the vapors will be formed, and on condensation of this vapor, we will be producing the liquid fuel. So, liquefaction of biomass is thermochemical conversion of biomass into liquid fuels by processing in a hot pressurized water environment. That is what is called a reactor. So, hot pressurized water environment, sufficient time to break down the solid biopolymeric structures to mainly liquid components. So, by doing this process, what we do is we will be breaking that solid biopolymeric structure into liquid components. So, or initially it is converted into vapor form, then it is condensed to produce the liquid form. It is relatively at low, the process actually is carried out low temperature 130 to 150 to 330 degrees Celsius only, and high pressure, but the pressure inside the cylinder inside the chamber will be very high, that is 5 to 200 bar, 5 to 200 bar, where biomass is fed into a unit as an aqueous slurry. See, the biomass is fed into the unit as an aqueous slurry. Aqueous slurry means the water is completely, it will be in the slurry form. The biomass provided into the liquefaction chamber is actually in the slurry form. Complete mixing of water and biomass, small sized biomass particles is mixed in the water to form aqueous slurry. And biocrude in liquid form is the product. So, finally, we will get biocrude in the liquid form as the product. So, as I have already told, some catalyst is also used during this reaction. So, catalysts such as sodium carbonate and pressurized reducing gas, usually hydrogen and carbon monoxide, are also introduced to the reactor to enhance the rate of reaction. So, for the complete for enhancement of the chemical reaction or speeding up of the chemical reaction, these catalysts are commonly used. So, liquid slurry is or biomass in slurry form is directly fed into the liquefaction chamber, or we will simply call it as a reactor. Inside the reactor, the temperature is around 150 to 330 degrees Celsius, and the reactor will be working at a very high pressure of 5 to 200 degree to 200 bar. Okay. This process used to get maximum liquid yields with higher quality than from the pyrolysis process. See, I have already told during the pyrolysis process also we are obtaining some liquid fuels, but the complete conversion is not practically possible, or in order to get the maximum liquid out of this process, we will be going for liquefaction. The process used to get maximum liquid yield with the higher quality than from the pyrolysis process. The product have higher heating value and lower oxygen content, which makes the fuel chemically stable. So, the final product will have the higher heating value, or heating value means by burning unit mass of fuel we will get more energy, it will release more heat. That is what is the meaning of heating value. So if heating value is less means more fuel is required to produce required heat. So that is the advantage of going for the liquefaction. In the liquefaction process, liquid yields are maximized by rapid heating of the feedstock to comparatively low temperatures. So during the liquefaction process, how we are increasing the yield is by rapid heating at moderatively low temperatures, so at comparatively low temperatures. The vapor is condensed. So by doing this process, low temperature heating at a rapid rate is done inside the reactor, but remember, inside the reactor we are having very high pressure, so the vapors are produced from this biomass fed into the reactor. This vapor is condensed from the gas stream and they are separated into two phase liquor. They are as follows. First one is aqueous phase. So the gas once condensed we will get two phases. First one is aqueous phase, second one is non-aqueous phase. The aqueous phase contains organic materials such as acetic acid, acetone and methanol. All these can be used as the fuel directly. The non-aqueous phase consists of oils and tar. So the second one is non-aqueous phase, that is either oil or tar. Liquefaction of the biomass can be achieved through two processes: liquefaction through pyrolysis without any gasification medium and liquefaction through methanol synthesis with gasification medium. Those who are interested in this area can please go through these topics also. You can study it by your own. So with that, I am concluding this session. In the next session we will be discussing about the important one among the thermochemical conversion of the biomass, that is gasification. Okay, so gasification we will be discussing in the next presentation. Thank you.